Welcome back, students. In this video, we continue to discuss trigonometric identities theory part. The earlier two videos we have discussed the trigonometry identity 1 and 2. Please check the video if you have not checked it earlier. So the tick mark, the green color tick mark are the ones which we have completed discussions. And presently we are discussing trigonometric identities. We are on the third trigonometric identity, that is cot square theta plus 1 is equal to cosec square theta. All these three are the same equations. So as we discuss this identity, you need to remember that this trigonometric identities have multiple forms. We are discussing those multiple forms in this videos as well. Kindly write and practice once or twice till you're familiar, because most part of your questions for your board exams are around trigonometric identities. So please familiarize well on these identities and its different forms. Then only you'll be able to solve these problems easily. I discussed the two identities in the earlier two videos. So please check them as well. Write and practice it. Excuse me, write and practice it. So now, how do we understand, or what the proof that cot square theta plus 1 is equal to cosec square theta? So this is derived from the first identity, sine square theta plus cos square theta is equal to 1. So now I'm going to divide the entire equation with sine square theta. When I do it, the first one becomes sine square theta by sine square theta. The second term becomes cos square theta by sine square theta, and the third field becomes 1 by sine square theta. Sine square theta by sine square theta is 1. Cos square theta by sine square theta is nothing but cot square theta, and inverse of sine is cosec square. So 1 by sine square theta is cosec square theta. So now you will understand why I said that all the three equations are same. Be it second identity or third identity, everything is derived from the first identity. So all the three are the same equations but different forms. Now this identity 3 can have two different forms. One is cosec square. What I'm doing is this I'm sorry, the audio went off. The mic was not working. So let me continue. I'm sorry for the break. So what I'm going to do is that cot square, I'm going to bring it to the other side. So cosec square theta minus cot square theta is equal to 1. Now see this as a square minus b square form. A square minus b square is nothing but a plus b into a minus b. So cosec square theta minus cot square theta is equal to cosec theta plus cot theta into cosec minus cot theta is equal to 1. They both share an inverse relation or a reciprocal relation, means one is the reciprocal of the other. Cosec theta plus cot theta, I keep it on one side, and this I push it onto the other side and it goes to the denominator. So cosec theta plus cot theta is equal to 1 by cosec theta minus cot theta. The another possibility is I can retain cosec theta minus cot theta on one side and push cosec plus cot theta on the other side. Kindly write and familiarize yourself, because there are some problems which will show you this as one of the LHS, and when you see this you should be clear that this is related to trigonometric identity 3. So familiarize yourself well, and going to the second form, what I'm going to do here is I'm just going to push this minus 1 to the other side. So cot square theta is equal to cosec square theta minus 1, and I'm going to decompose this a square minus b square form into a plus b into a minus b. So cosec square theta minus 1 becomes cosec theta plus 1 into cosec theta minus 1, which is equal to cot square theta. So this I can rearrange keeping one particular form in one side as cosec theta plus 1 is equal to cot square theta divided by cosec theta minus 1, and or another format is cosec theta minus 1, I'll have it on left hand side, and onto the right hand side I bring cot square theta divided by cosec theta plus 1. Please write, familiarize yourself of this different forms. In the next video, we'll discuss a few problems. We'll start with a few simple problems and then move to the complex problems. Thank you till bye till then.